Good morning, Super Scholars. I'm going to go over lesson 10.5, area of trapezoids, just because we're not going to have a lot of time this afternoon in our other meeting. So, because we have other important things that we need to discuss. So I'm going to share my screen and get started. Make sure you have your book open to page 405 so we can go over this lesson, the area of trapezoids. So again, how can you find the area of trapezoids? Yesterday and the day before, we learned a formula for that, and that's here. So here is our formula, the area of trapezoids. A equals 1/2 times the sum of base 1 and base 2 times the height. Okay, base 1 and base B1 and B2 are the two bases, and H is the height. Okay, let's see what it says up here. Any parallelogram can be divided into two trapezoids with the same shape and size. The bases of the trapezoids B1 and B2 form the base of the parallelogram. The area of each trapezoid is half the area of the parallelogram. So the area of a trapezoid is half the product of its height and the sum of its bases. Pretty much what this says. So if we look over here at the diagram, you can see that this whole thing is a parallelogram, and they cut it into two trapezoids. So this side here and this side here, those are the bases. Those are the two parallel sides. Parallel means that in between, it's a straight line that has a 90-degree angle. So that's a straight line, and the angle that this line forms and this is a 90-degree angle, like the corner of a rectangle or the corner of a square. So that 90-degree angle means that the opposite sides are parallel, and so those are the bases. Okay, so whenever we're looking for the bases of the trapezoid, we have to find the sides that are parallel to each other. If we look at these sides, they're angled, and if we continue the lines up, they would cross each other. If you continue these parallel lines forever and ever, they will never cross because they are parallel. Very good. Let's continue. Mr. Desmond has tables in his office with tops shaped like trapezoids. The diagram shows the dimensions of each tabletop. What is the area of each tabletop? Okay, so if we look at these questions here, how can you identify the bases? Again, we're looking for the parallel sides. Okay, I see that this is an angle, this is an angle. So those are not parallel because if you continue the lines, they will cross. These two, I see that little 90-degree angle here. So I know that here's, no, that's not what I wanted. I want this one. So here's base 1. Here is base 2. So this is B1. And this, it doesn't matter which one is B1 or B2 as long as you find the two bases. So if we answer this question, how can you identify the bases? The two parallel sides are the bases. The two parallel sides are the bases. Okay. How can you identify the height? And the height is the straight line in between the bases and forms that 90-degree angle. Height forms a 90-degree angle with each of the bases. Perfect. Okay. So there's a 90-degree angle here with base 1, and also here. So this forms a 90-degree angle here and a 90-degree angle here. So we know that those two are parallel. So this number here, that's h, that's the height. Okay. So now we're going to use our formula. A equals half times the sum of base 1 and base 2 times the height. We're going to substitute our values of the two bases. So we have 1 and 6/10 plus 0 and 9/10 times our height. The height is 0 and 6/10. So now we're going to add these two bases, 1 and 6/10 plus 9/10, and that equals 2 and 5/10. And then we need to multiply. So we can multiply a half by either one of these. It's fine. I think it'll be easy to do half of 6/10. Half of 6/10 should be 3/10. But in here they're multiplying 2 and 5/10 times 6/10 first. So we can do that. So 2 and 5/10 times 6/10 equals 1 and 5/10. So 1 and 5/10. So here we're putting 1 and 5/10 times a half. That equals 7/500. So this tabletop has an area of 7/500 meters squared. Remember, it's okay to use a calculator once you have all your numbers in the right spot, base 1, base 2, and your height, and then you may use a calculator. Also remember to add first because those numbers are inside the parentheses. So we have to add those bases first. Let's move on to the next page. do some more. So example 1, they give us the formula again. A equals 1/2 times the sum of base 1 and base 2 times the height. We need to look at our diagram, our trapezoid, and figure out which ones are the bases. Remember, the bases are the two parallel lines. So we want to look for the flat ones. Usually it's the top and bottom. So I see, again, here's our 90-degree angle. Again, here's our other 90-degree angle. So these two are the bases. 9 4/10, 4 6/10, those are our bases, and the one in between, the line going straight up and down between, that's our height. And they say they already have the height over here, 3.5. So if we substitute our numbers, 9 4/10 is one of our bases, and the other one is 4 6/10. So we have to add those because those are inside the parentheses. 9 4/10 plus 4 6/10. I know 6 and 4 is 10. It's going to give me an even number. 9 and 4 is 13, but I have to carry the 1 from the 10. So it's going to equal 14. So 9 4/10 plus 4 6/10 equals 14. And that makes it easy to multiply times 1/2. 1/2 times 14. It's nice when it works out like that, is 7. We have 7 times 3.5. 7 times 3.5 equals 24 5/10. Again, it's okay to use a calculator just as long as you have your numbers in the right spot. So the area of the trapezoid is 24 5/10 centimeters squared. Make sure you have all the answers there. Let me erase these, and I will move it down so we can go on to example 2. Now we've done problems like similar to this in the other lessons for the parallelogram and also for the area of the triangle. They give us the area of the trapezoid. We have to find the missing part. In this problem, it's the height. We don't know what the height is, but they do give us the two bases. So all we have to do is follow our formula again, substitute all the numbers. The area of the trapezoid is 702, so we'll put that here. We know the values of the bases, so we'll put those here. 20, the other base, because here again, the parallel lines or the 90-degree angle is here. And usually the bases are in between the height. So wherever that height is, that dotted line, the two that those connect, those are the bases. So we have 20, and then we have 34. Okay, and we don't know the height still. So again, 20 and 34 are inside the parentheses. We need to do those first. 20 plus 34. It's relatively easy, 54. Okay. And then we're going to multiply 1/2 times 54. I know 25 times 2 is 50. So I need 4 more. So I'm going to say that 27. So half of 54, 27. If I have two 27s, that's 2 more than 25. 2 plus 2 is 4. So 50 plus 4 is 54. So that's how I was thinking about that. So now we have 27 times h, but we want h by itself. So in order to have a variable by itself, we're going to do the opposite. We're going to do the inverse operation. So here I see multiplication. Right here we have our 27. And the opposite of that would be to divide. So as we draw a line underneath, we're going to divide by 27. Makes those will cancel out. And if we divide by 27 on that side, we have to divide by 27 on this side. Okay. So I know that 27 divided by 27, we're going to cancel those out. We're just going to be left with h. Here's our h. 702 divided by 27 equals, drumroll, 26. Okay, so 26 is our height, 26 inches. So the height of the trapezoid is 26 inches. Okay. That's going to conclude the lesson for today. Make sure you use that formula each time. If you're finding the area, you just plug in the numbers on this side. If they give you the area, then you need to plug in the area on this side and probably find the height. Otherwise, it's just regular math. Use your calculator if you have one. And good luck. Let's just really quick look at the next page to see what we're doing. Okay. So I see, yep, number 1, 2, and 3, you're just finding, actually number 1 and 3, you're finding the area. Number 2, you're finding the height. So this is just like example 2 on the previous page. These are just like example 1 and the first one on the first page. Again, find the area for number 4 and 5. Find the height. So they give you the area. You have to find the height for number 6 and 7. Okay, use the formula, use the examples we did together on this page to help you out. If you still have any questions, ask at our Zoom meeting this afternoon. I'll see you later, Super Scholars. Thanks for watching.